Hi student, today we are going to discuss about Frenkel defect. Frenkel defect is also stoichiometric defect. Now let us understand what is stoichiometric defect. The stoichiometric defect is the defect in which the ratio of the cation to anion remains same before and after the defect. It is called a stoichiometric defect. What is stoichiometric defect? The defect in which the ratio of the cation to anion remain same before and after the defect is called a stoichiometric defect. Now let us understand the Frenkel defect. The Frenkel defect is a stoichiometric defect. The Frenkel defect arises due to the dislocation of ions from its crystal lattice. Dislocation of ions from its crystal lattice. Okay, some of the ions uh, dislocated from its normal position. Okay, it located in another interstitial site. It is called a Frenkel defect. The ion which is missing from the lattice point occupies an interstitial positions. The ion which is missing from the lattice point from its normal position, it occupies an interstitial position. This defect is shown by ionic solids in which the cation and anion differ in size. The cation and anion differ in size. Such a kind of ionic solid shows the Frenkel defect. So this defect does not affect the density of the crystal. Density of the crystal. For example, we are taking the silver bromide crystal. Silver bromide crystals. This is the silver bromide crystal. We are taking the silver bromide crystals. Here, the small silver ions leaves from its normal site. The small silver ions. This is the small silver ions. It's the Ag plus ion. Missing Ag plus ions. It leaves from its normal site and occupies an interstitial position. Occupies an interstitial position or interstitial site or a gap between these atoms. This is the silver ions in interstitial positions. This is a missing Ag plus ion. This missing Ag plus ion occupies an interstitial position of the crystal. Same within the same crystals. Okay. So this type of defect is called a Frenkel defect. In AgBr crystals, the small Ag plus ion leaves from its normal site and occupies its interstitial position. Interstitial position is called a Frenkel defect. So now let us see some example. Other examples for Frenkel defect is zinc sulfide, silver chloride and silver iodide. These are the other examples of Frenkel defect. Zinc sulfide, silver chloride and silver iodide. So I hope you understand, student. So the Frenkel defect arises due to the dislocation of ions from its crystal lattice. The ion which is missing from the lattice point occupies an interstitial position. This defect is shown by the ionic solids in which the cation and anions differ in size. Unlike a shortcut defect, the Frenkel defect does not affect the density of the crystals. For example, silver bromide. But in Frenkel defect, it shows low electrical conductivity. Frenkel defect, it shows the low electrical conductivity than Schottky defect. Low electrical conductivity than Schottky, it shows it shows low electrical conductivity. Okay, student, do you understand? Thank you. Thank you, student.